Hi, everybody. So up to this point, we've been talking about different elements and how they're combined into molecules and how different molecules interact with each other in chemical reactions. We talked a little bit about pH as well. So now we're going to turn our attention to those molecules that are found in living things. Any chemistry, that is study of the interactions of atoms and how they're arranged and rearranged with each other, chemistry, that happens in living things is called bio for life, chemistry for the reactions that are happening. So biochemistry is where we're going to turn our attention now. So it's any chemical reactions that are happening inside the cell or any living organism. Now, like most of science, scientists and biochemists have made sense of the world by classifying things. And so they've classified different compounds that are found in living things. And we're going to do that as well. We're going to identify how they've classified different molecules. So they've taken all molecules and put them into two categories. There's organic and inorganic. Those are the two major categories of chemical compounds. And you all know the term organic, right? From the grocery store, you go in and you can see there's some fruits and veggies that are organic. And that means that they're grown without pesticides and other compounds that are considered unnatural. But that meaning, that grocery store meaning of organic has nothing to do with the term as we're going to use it. When we talk about organic, we're actually talking about a very, very specific definition. And that is, it's any compound that has both carbon and hydrogen. There are some exceptions, but for our purposes, it has carbon and hydrogen, it's organic. If it has neither of those or only one of them, it's inorganic. So it has to have both to be organic. Now, there are plenty of things that you can get at the grocery store that aren't organic food, like oranges that aren't organic. And they have plenty of organic compounds in them, like sugars and some lipids and some other things. So this has absolutely nothing to do with the grocery store definition of organic. Okay, so carbon and hydrogen, it's organic. If it's missing one or both of those, it's not organic, it's inorganic. So let's take a look at some examples. We have H2O, you all know that's water, two hydrogens connected with one oxygen. Is that organic or inorganic? Well, we can see it doesn't have carbon. And so without carbon, it's got to be inorganic. It's a really important molecule to living things, right? There's lots of water in living things, but it's inorganic. So that tells you that the term organic has nothing to do with whether it's in living things or not. Living things are made of organic and inorganic compounds. This is really just to classify molecules, and they can be found inside of living things or outside of living things. Okay, CH4, methane, explosive gas. We don't make methane. Cows burp up some methane, and methane can be found underground. It is definitely an explosive gas. Is it organic? You betcha. It's got carbon and hydrogen, organic. All right, how about carbon dioxide? That's something that we make in our cells. We'll talk about that in large detail later. But carbon dioxide, organic or inorganic? Inorganic, it's missing hydrogen. So this time it has carbon, but no hydrogen. Number 4 is a molecule we're going to talk about lots and lots for the next few days, C6H12O6. That's a simple sugar called glucose. Is it organic or inorganic? It's organic. It's got carbon and hydrogen. It can have other stuff like oxygen, but as long as it's got both C and H in it, it's considered organic. How about ethyl alcohol, C2H5OH? Organic. It's got carbon and hydrogen. Number 6 is tricky. That looks like it might be organic because it's got an H and a C in it, right? But that C is Cl, not C for carbon, that's Cl for chlorine. And so this is hydrochloric acid. Is it organic? No, it has no carbon. It has only hydrogen. So HCl is inorganic. Important inorganic molecules that we have to keep track of that are in living systems, biology, that's what we're studying. We're studying living systems. So these are important inorganic molecules in living systems. We've got water, carbon dioxide, and oxygen. Those are all inorganic. They're missing. Water doesn't have carbon, carbon dioxide doesn't have hydrogen, and oxygen, oxygen has neither carbon nor hydrogen. And that's the distinction between organic and inorganic compounds.